Geotechnical Engineering, Part A, Soil Mechanics, Session 10, Chapter 3, Weight Volume Relationship. So let's solve some more problem in weight and volume relationship, Chapter 3. So in example 1, we have a 40 kilogram of water which has been added to a 1 cube meter dry sample of soil, which has a weight of 1600 kilograms initially. So this is our dry sample, just soil and air. There is no water, and the total weight is 1600 kg, and it's just the addition of plus 400 kg of water, and its volume then increased by just 50 liters, and each liter, 1 liter, is equal to a 1000 a meter cubed. So uh, we want to calculate the saturated unit weight just before and after adding the water to the sample. So we just add 40 kg of water to our dry sample. Its volume just increases by 50 liters. So it just goes up by the amount of 50 liters. We want to calculate the unit weight, the saturated unit weight of our sample, both after and before adding water to the sample. So let's see how we can approach this problem. So if you remember from the formula, gamma saturated or saturated unit weight is Gs plus E over 1 plus E. Specific weight plus a void ratio over 1 plus void ratio times unit weight of water. And that's the formula. Then you are working with the graphical shape, which is a better understanding of the issue. It's recommended to use this formula for gamma saturated. Gamma saturated or saturated unit weight is the total weight over total volume, and that's a Ws plus Ww plus a W prime of W. So that means weight of soil plus weight of water plus weight prime of water, which is the water which just fills uh, the extra water. And over the volume total, which is S plus VW again plus V prime W. We have a VW, and that's V prime W. So if we want to calculate let's see what's happened to our sample. So if you look at keep a closer look to the dry sample and wet sample, so it means after adding 40 kg and each liter of water is equal to 1 kilogram. So that's something like 400 liters. By adding 4 kg of water or 400 liters, just 350 of that just comes to the same level, and just there is addition of liters. So it means the 350 first this amount of water first fills the gap void ratio, so volume of air. So there was this much air capacity of handling 350 more extra water, 350 water. Then as soon as it just saturated, then it just goes up by 50 liters. So that's before and that's after. For before scenario, gamma saturated is a weight of soil, and if you just fill the whole air area with water, that's a saturated meaning, and that's a from the second figure we easily understood that's 350 communicates there. over the volume total, which is 1 cube meters, which is provided. So it just gives us a unit weight of what? 1950 kilogram per cube meters for V4 saturation for scenario 1. And for scenario 2, that's easier. That's 1600, which is the soil, weight of soil, 350, which is the part for water, and plus extra water, which is a 50. Each liter is equal to 1 kg. Plus, this time the unit weight increased by 50 liters. So each liter is 1,000th of cube meters. So that's a 50 over 1,000, 50 cube meters. That's one cube meter initially plus this addition to convert to cube meter, and it just gives us a gamma saturated after after adding this much of water. It's just 1905 kg over cube meters. Let's solve this graphical solution gives a firm understanding of what's happening, and it's strongly recommended. So let's solve a second problem in weight volume with the same approach. So if we have a 250 cc of water, and cc stand for centimeter cube. So that's C stand for centimeter cube. So that's centimeter cube. 250 centimeter cubed of water has been added to a soil sample. This time it's not dry. Has a moisture of a something like a 0.12% of water. Say W percent of 12% of water, and then its volume, the total volume is 800 centimeter cubed. Then it just increased to 850. Like previous problem, likewise, it just the amount of first it just need to fill the 250, just 50 of that has induced a rise, so left with a volume of air is 200. So let's see how that goes. So if the specific gravity GS of the soil sample is 2.65, we want to know what is initial saturation ratio of the sample. So we want to know what is SR for this sample. So let's attempt the problem. So for initial sample, Vs plus Vw is 800. So if we just want to consider volume of soil plus volume of W, not the air. So if we add 250 to this sample, 250, it just rise by 50 cc. It means 200 of that, it just goes somewhere to the void ratio, to a volume of air. So if we just subtract 800 minus this 200, which is subtraction from 250, which is total of this one minus the rise, it just means the leftover is just somewhere in volume of air. So if we just subtract the volume of air, V air, that is 800, which is the initial of the first sample, minus 200, it just gives us a 600 centimeter cubed or cc for Vs plus Vw. If we just jot it down like equation 1, so Vs plus Vw is equal to 600 cube meters, and that's our equation 1, and that's in terms of cube centimeter cube. And if this is our first equation, Sr We do know saturation ratio or saturated ratio is the volume of water which fills the void. Hmm? And have an extra a piece of the problem, that's omega percent. Omega is volume of water, weight of water over weight of soil, which is provided in problem statement to be 0.12%. If you remember, sample one was not dry, that was has a bit of moisture content. And if you rewrite the moisture content based off the volume relation, this is weight relation. If you just write it based off volume relation, if you remember, that's 1 over gs times volume of water over volume of soil, because we already have a kind of relation between them. And if you just rearrange this equation, gs is already provided to be 2.65 in problem statement. We can have a relation, second relation between vs and vw, point a 318 vs is equal to vw. And if we call this equation 2 and solve equation 1 and 2 simultaneously, it just 1 and 2 simultaneously gives us a vs volume of soil is almost 455 centimeter cubed, and vw volume of water is 145 centimeter. And then SR is volume of water, which it just directly goes to a numerator over volume of void, which is 100 volume of water plus volume of air. If you remember, we just calculate 200 is related to the air, entrapped air within the first sample. So that gives us a SR is equal to a saturation ratio of 40%. We will solve more problem. Thank you.